nice and tall. Sitting up nice and tall, spine is long, shoulders are soft. You're welcome to close your eyes, join in, or just listen. Palms at your heart and Namaskar Mudra. Om Sahana Vavatu Sahano Bhunaktu Sahavidyam Karavavahaye Tejaswi Navaditamastu Ma Vidvisha Vishai. Om Shanti Shanti Shanti. My name is Kusum Joy T, and I'm a yoga teacher and student at Vivekananda Yoga University, the world's first yoga university outside of India. Presently, VaYU is offering an online Masters of Science program that has a unique flipped classroom approach with weekly faculty-student synchronous interactions. We are also planning on starting a doctoral program and an MBA in integrated health. VaYU is collaborating with leading hospitals and universities across North America to offer students a comprehensive learning experience. We are bringing to you a series of informational webinars where all of the distinguished speakers are accomplished and leading experts in their respective disciplines. Some will also be teaching and research faculty at VaYU. Before we begin, we would like to recognize our collaborators. Thank you to Vyasa LA, Samskrita Bharati, Heartfulness Institute, North South Foundation, Federation of Indian Physicians Association, and the American Academy of Yoga and Meditation. This series would not be possible without your kind support. Attendees, you will be muted throughout the session, so please type your questions in the Q&A chat box, and they will be answered at the end of the discussion. Now it is my great honor to introduce Dr. Richard Fletcher. Dr. Fletcher directs the Mobile Technology Group within the MIT Mechanical Engineering Department, which develops a variety of mobile sensors, analytical tools, and diagnostic algorithms to study problems in public health and behavior medicine. Over the past 20 years, Dr. Fletcher has done extensive work in India, collaborating with organizations serving the rural and urban poor, with ongoing research studies funded by the NIH, the Bill and Melinda Gates Foundation, USAID, Vodafone, and the Tata Trust. In the US, Dr. Fletcher works in the area of behavior medicine and public health, addressing the health disparities and important issues such as drug addiction and mental health. Bridging together the fields of engineering and medicine, Dr. Fletcher's research utilizes a variety of mobile technologies, wearable sensors, and Internet of Things for use in behavior monitoring as psychological and behavioral interventions. Dr. Fletcher holds undergraduate degrees in physics and electrical engineering from MIT, and also received both his master's and PhD from MIT in the area of information technology with a concentration in physics. Prior to focusing on health, Dr. Fletcher worked in the area of wireless sensors and radio frequency identification, RFID, for 20 years, including 5 years with the US Air Force Research Lab and 20 years at the MIT Media Lab, producing over 20 US patents and several spin-off companies. Dr. Fletcher also holds a faculty appointment at the University of Massachusetts Medical School, Department of Psychiatry, specializing in technologies for mental health monitoring and wellness. Dr. Fletcher has family roots in Colombia, South America. If you weren't already impressed and intrigued, we certainly are now. Over to you, Dr. Fletcher.
But it's a pleasure to be with you all and have the opportunity to share some of my work with the VaYU community and the yoga community at large. I think it's exciting to start bringing some of these practices outside of India and start new communities of yoga here in the US. So I'm a technologist, I'm a research scientist at MIT, and I also have a faculty position at University of Massachusetts Medical School in the psychiatry department. So I'm interested in mind and body together. Okay, I'm gonna start sharing my screen and I will begin my talk. Okay, hopefully everybody can see my slides. Can you give me a thumbs up if it looks okay? All right, good.
Yes.
All right. Okay, so as a very quick introduction, I just want to say I have a pretty long and close history doing projects in India, and some of this started when I was a student. So I founded some companies. At the beginning, I was interested in internet connectivity for remote villages. So we brought internet and e-commerce to remote villages in India. Then I worked in the milk collection field, doing instrumentation for milk testing and also tagging cows. And I've done work in air pollution monitoring. This was mostly Tamil Nadu and Chennai. And more recently, I've done a number of projects with community health workers. This happens to be with the Public Health Foundation of India. And this is more related to some of the health work and global health work that I do currently. And I've worked with a variety of clinics throughout India, building instrumentation for doctors. But all of this is based on mobile phones, portable and wireless sensors that could be used to measure signals in the body. So with that background, I also wanted to say that one of my inspirations when I was a student was I studied the work of J.C. Bose, from Kolkata, who lived about 100 years ago. And he was one of the pioneers in wireless technologies. And he also, as some of you know, J.C. Bose also worked with plants. So he was very interested in studying the connection between all living things, not just humans, but animals and plants as well. And he built a lot of ingenious instrumentation for monitoring the life of plants and the environment around plants. So that was some of my early inspiration, which then later led to my work in health instrumentation. So I just wanted to mention that. And this is one of pictures of one of the early instruments that I built that monitors a plant. And it was a car that moves around based on the neurological signals of the plant. Okay, so let's go ahead and start. So for this talk, I'm going to start with just a general overview of disease and give you some motivation for why I'm interested in yoga and how I think about yoga. So if you look at several hundred years ago or even further back, most of the diseases that really affected humankind were infectious diseases. So these are communicable diseases, things like cholera or other sorts of infections or diarrhea that could be communicated through, let's say, dirty water or things in the air or some kind of insects. But then in the 1990s, we passed an important milestone in the humankind, which is for the first time in history, the non-communicable diseases is now a larger burden of our diseases compared to communicable diseases. So that means we are now, as a world, we're starting to be able to control communicable diseases, but non-communicable diseases are becoming a larger problem. And what are these? These are things like cancer, diabetes, cardiovascular disease. And even if we think about mental health, which is obviously an important part of our body, depression is one of the largest causes of disability. So we can't forget that. And all of these things are increasing. So every year, the numbers get larger and larger. Now, some of this is just simply the fact that there's a aging population. The number of older people in the world is increasing every year. And of course, more in some countries than others. But the other thing that I want to mention that's related to this is, in addition to the diseases that I mentioned, there's also Alzheimer's disease, which is also a very important problem that's emerging for the older population. So what are the causes of these non-communicable diseases? There's genetics, but then there's things like environment and behavior. And if you have some control over your environment, for example, what kind of stove you cook with, or the ventilation and so forth, you could really combine environment and behavior to some degree. And I basically simplify it down to two causes: genetics and behavior. For example, to show you how important behavior is, if you look at people think that approximately 40% of cancer is preventable. And what are these 40%? So these include risk factors such as these that you see on the slide: smoking, drug addiction, and other sorts of behaviors that are not healthy. And because of this reason, we now have fields of medicine known as behavior medicine. And these are the people in the clinic or in the hospital that will counsel you about your diet, how you're sleeping, exercising, these sort of things, your lifestyle. So these are sort of things related and diseases related to our lifestyle that we can change through our behavior. But what I would like to say in this talk, and sort of emphasize in this talk, is that there's an important component beyond just genes and behavior. So we know that genes and behavior cause these non-communicable diseases, but there's also emotion. So emotion is an important component of disease. So, and we know very well that one of these important components are items such as stress. And through research, people have shown that stress, or sort of these negative emotions, they correlate with addictions, things like smoking or drinking. They also correlate with obesity, BMI, how much weight we gain. They also correlate with diabetes risk factors, with glucose levels and insulin levels. And one example of a published paper back from 2007, this is a photo of that from that paper. And there were two identical mice. And these two mice are genetically identical. So they're twins, essentially. And both mice were kept in cages, and they were both fed the same exact diet. So why is one mouse larger than the other? Well, the difference is one mouse was allowed to move around freely without any interruption, and he was allowed to rest at night and have a normal sleep. The other mouse on the right was given stressors. So basically, they played music and distracting sounds, so the mouse was not allowed to relax, and that stress actually caused that mouse to gain weight. So there's just one example showing how the amount of stress, even given the same amount of food, can produce increased weight gain. And now we know that there's a strong connection between the body, between the brain and the gut. So our digestive system is connected through different nerve pathways to our brain. And we now know that some of these are involved in other sorts of chronic diseases and other types of diseases. Some of these people didn't even realize how connected they were between the mind and the body. And of course, people who work in Ayurveda, for example, know this very well, how important the diet and food and our digestion is to our health. So what does this imply? This means that we need to care about both the body and our mind. So if emotion is important for disease, then we need to care about our thinking, our stress, our emotions. We need to be able to be aware of that and also have some way to regulate that properly. So this all means holistic health, the brain and the body. But there's some challenges. And one of the challenges is actually in education. When we go to school as a child, we're never really taught in school, how do we detect brain illness, right? We are taught that if I want to have a good body, I need to exercise, I need to do, push-ups or sit-ups or something, or I need to run. But we are not taught in school too much about how to take care of our brain. So what sort of exercises do we need to do to take care of our brain? And this is not something that's often discussed. So this is something that we could improve in our education. And some other things that I think are important to point out is the word health is often used very loosely, and we don't often define what we mean by health, right? So in modern medicine, and when I say modern medicine, I mean mostly Western medicine. In allopathic medicine, we rely a lot on tests, laboratory tests, and we rely on machines. And oftentimes, sometimes we feel that when we go to a hospital, we're just looking at these numbers, right? So this is in this slide, I show some pictures of like a blood test results. So in our blood test results, we see all these numbers, and sometimes we feel that health just means having the right numbers, right? And but then I don't know what people in the audience think, but is this really what health means? And in my opinion, I don't think health is just numbers. I think there's more to health than just that. And in my opinion, I think health is really a better definition of health maybe is resilience. So what I mean by that is training our body and teaching our body how to respond to psychological stress and physiological stress. So when we are attacked by a disease in our body, how does our body respond to that? So I'm talking about things related to like our immune system, our immune response. But it applies to all different kinds of stress, biological, physiological, as well as psychological. And if somebody is really strong and healthy, you will have this resilience. And I think this is maybe a better way to think about health. Okay. And I'd like to make a couple other points here. One is about just being in balance. So I think another aspect of health is about being in homeostasis, having a balance. And when I say balance, I mean balance in almost everything we do, what we eat, how we the activities that we use with our brains and as well as our bodies. So having moderation is always a good thing. The other thing that I think is important to health is being aware of your body and your thinking. So this is sometimes known as metacognition or interoception, but basically, obviously, if we don't have this, we will not realize that there's a problem, right? So it's very important that we have an awareness of ourselves. So turning our mind's eye onto ourselves. And these are all aspects that people who practice yoga know very well. So I think that's one reason why, or these are some of the reasons why I think yoga is a very interesting field and an interesting sort of practice to learn, because it can address all these different aspects of health. Now, the question for this talk is, what is the possible role of technology? So, what does technology have to do with any of what I just said? So I'm gonna, in the next few slides, I'm gonna explain a little bit about how technology can be integrated into some of what I just said. So first, I'm gonna mention some of the technologies that are being used around the world by different research groups. And then I'll sort of introduce the area that I work on. So the first one is, as most of you know, the brain has its own electromagnetic fields that it produces, and you can detect those. The magnetic fields are very tiny. So some people study the magnetic fields of the brain, but those are very hard to detect, and you need special superconducting magnets or very sensitive magnetometers. So the most common way of studying the electromagnetic fields is just looking at the electric potentials by putting these electrodes on your head, usually through a cap. You can get one for adults as well as babies, and then as some of you know, when you look at the signals from different parts of your brain, you see, sorry, the different parts of your scalp, you see these signals, these potentials, and the potentials vary with time and space. And you can divide up these signals into frequencies. So you could say, okay, let me look at high frequencies and low frequencies. So these are known as brain waves. So these frequencies are much lower than, for example, our mobile phones or Wi-Fi. So these frequencies are quite low. But so among the higher frequencies, such as gamma waves, those are around, up to, let's say, 100 hertz or so. And people are interested in that for looking at concentration, things like Alzheimer's disease and learning. But then these lower frequencies, people are studying those to look at meditation and relaxation and sleep, for example, that produces some very low frequency waves. And of course, this is a simple, a simplistic view of it, but as I mentioned, people have sort of studied these brain waves and seen what brain tasks are associated with different frequency brain waves. And these brain waves also have different structures. So it's not just a frequency, there are actually structures that you can see in the waves. And some of these are used in the studies of sleep. So as you know, there's different stages of sleep, and there are structures called spindles, which you can see in different stages of sleep. And this part of what people study, if you do sleep research. So now, going back to the technology, what is new in the past 20 years or so is now we have very portable instruments and tools for looking at brain waves. So people have built these sensors into eyeglasses that have a wireless Bluetooth connection to your phone. They also have these headbands that you could wear. And this gives us the ability to do work outside the lab and to do experiments and measurements outside the lab. And you can use this together with phones to do biofeedback. So you can use your phone the phone can guide you to do, let's say, a breathing exercise, or you can listen to music or some sort of audio stimulation. And at the same time, you could be looking at your brain waves, the change in your brain waves. So you can use this to train yourself to change and modulate your brain waves and other sort of signals. So this is currently being used in education and learning, as well as sleep meditation. And as I mentioned to you, there's a lot of emerging work being done in Alzheimer's disease. So besides that, people are also interested in looking not just the waves produced by but also looking inside the brain, the structures of the brain, what parts of the brain are being active. And for that, some people are interested in mapping the structures, the physical parts of the brain, but also some people are interested in mapping the connections. How are different parts of the brain connected? And what functions do the different parts of the brain do? And what tasks are they related with? Are they related to speech or to hearing, et cetera? And of course, the main instrument that we use for this is MRI, magnetic resonance imaging. And this is generally a very large instrument, very expensive. So it's difficult to get access to this. So it's not something that you can have in your home, for example. But if you do have this instrument or have access to it, you can do very nice experiments looking at different parts of your brain and see the activity in your brain while you do different tasks. So this is called, known as functional MRI. And this is a very large proportion of what we call modern neuroscience is dedicated and using these tools of magnetic resonance imaging and also using artificial intelligence to help analyze the signals. And one of the areas of research which is still very much open and very new is studying consciousness itself. So here's a figure from a recent paper, from 2018, some people asking about, what is consciousness and how, where does it exist and how is it generated in our brain? So people are actively using some of these tools to investigate very deep questions, about consciousness and human life. So getting back to emotions, I now want to talk about affect and how that relates to the work that I do. So so there are many different parts of our nervous system, but the part that's related to emotion is generally considered the autonomic nervous system, and is controlled by and structures such as the amygdala play a very important role in these structures. So it's located essentially at the center of your brain, like between your ears. And as some of you may know, the autonomic nervous system can be divided into two parts, and they balance each other. Okay, so there's a sympathetic and a parasympathetic. So the sympathetic nervous system is what's generally creates the signals that you associate with stress. So basically, like it increases your heart rate, it makes your palms sweat. So it essentially makes you feel a little bit more what we would say stressed. And then parasympathetic is the opposite. So it's often related more with stimulating digestions, slowing the heart rate, and these two act in balance. But what I want to mention here, as you can see on this slide, is that the sympathetic and parasympathetic are connected to many of our organs, and many of our organs are controlled by both the parasympathetic and the sympathetic. So on this slide, you can see some of the effects that each one of those has, which I just mentioned. And the other thing I want to say is so even though we cannot see these signals in the brain directly, if we don't have a fancy MRI machine, we can measure some of these organs, and that way we can indirectly look at autonomic nervous system activity. So that's generally the approach that we take, is by studying some of these other activities in the body and sort of indirectly trying to understand what's happening with our autonomic nervous system. So the autonomic nervous system, that I just presented, is this section of this slide, which is in the green, outlined here in green. And as you can see, it's connected to other parts of the nervous system. So as you can see that if you're able to access or have some way to monitor the autonomic nervous system, it also has an indirect effect and is indirectly affected by these other parts of the brain as well. And these feedback loops inside the brain are actually quite complex, and there are other fields of neuroscience which are actively studying these as well. But one of the main interests in yoga is that you could think of yoga as a way to sort of bridge or to access the autonomic part of our nervous system. And yoga teaches you different techniques, and so if you living in our conscious brain or doing active activities, there are methods you can use to help modulate or access things that are generally under autonomic control, such as our heart rate, for example, heart rate variability. So these what I'm highlighting here are these organs, as I mentioned, and one of the most important organs, of course, is our heart. So one of the probably the most widely studied organ in terms of autonomic activity is your heart and your heart rate. So as you know, we are not a machine. Our heart, in a healthy human, the heart is not like a clock that's just where the blood is just pumping. The heart is beating regularly. That is actually not healthy. So a healthy heart rate is actually one that jumps around. And why does it jump around? It jumps around because that means your body is compensating for a variety of things. So your heart rate is constantly speeding up and slowing down, and that's a healthy thing. That means your body is healthy and it's actually working properly. So we actually want to see complexity and variability in this heart rate. So one of the things we study is heart rate variability. And when the heart rate variability goes down, then we know something is generally wrong. Either it's stress or it could be disease, some kind of disease that's preventing it. Maybe you're sick. So here's an example, as I mentioned, if you don't have high heart rate variability, like a machine, your heartbeat, your pulse might look like this, but in a healthy person, it actually jumps around. So the spacing between your heartbeats is actually variable. And this is a typical waveform from an electrocardiogram, which are those electrodes that you put on your heart, and you could measure your heartbeats. And this slide shows the heart rate as a function of time of a few different people who are sick. So these are examples of physical sickness, like physiological problems with the heart that causes changes in your heart rate variability. So as you can see, if you have congestive heart failure, your heart rate variability is very low, and that's a very unhealthy condition. But it can be improved by medicines, but also by different exercises you can do to help improve your heart rate variability. And as I mentioned earlier, the heart rate variability can also be reduced when you have psychological stress. So as shown here in this diagram. And because our heart and our breathing are connected, they're coupled together, you can actually have some influence on your heart rate variability by using breathing. And this is, one of the fundamental principles behind pranayama. So, we know physiologically that, when you inhale, your heartbeats move closer together. When you exhale, your heartbeats move further apart. So, as you can see, there's an example from, one of the papers I found online that, normal breathing, here you see the normal breathing as a function of time on the bottom trace, and on the top, you see the heart rate, which is bouncing around. And you can see if you speed up your respiration, do fast, what they call fire breathing, it actually, affects your heart rate variability. But if you do the slow, kind of more paced breathing, like 6 breaths per minute kind of thing, you could see that you get this nice variability in your heart rate. So if you see it on the top there, you can see that your heart rate is going up and down, and that's a nice healthy variation. So this gives you kind of a nice relaxation. And this also has changes on the brain, which have also been studied, through MRI. So they have people who can do pranayama inside the MRI machine, and you can see the effect it has on your brain. So one of the areas I'm interested in is, okay, how can you measure these autonomic signals, but without using wires? Because if we want to use these technologies in our everyday life, we don't want to have too many wires attached to our body, right? We want to have some way that's more comfortable to measure our signals. So one of the devices that I developed is a portable radar unit. So basically, it's a very low power device that's essentially looks at the energy reflected from your body, and that includes your heart. So when your heart beats, you actually get a signal back, and the signal looks like this. So you can see your individual heartbeats, but you also can see your respiration, which is that big, the lower frequency wave that you can see there. And I've also made a very portable unit that's very small that you can wear over your clothes. So this is like a little badge that you can put on over your clothes, and it's measuring your heartbeats through your clothing. It's measuring the motion of your heart. And on the right there, you can see on the top is a signal from this microwave radar device, and on the bottom is an ECG signal that's done simultaneously, so you can see how the signals line up. The other way that people have used, the other methods that people have used to measure heart rate is by looking at the color of your skin. So it turns out that obviously, since blood is pumping through our skin, the color of our skin is actually changing. And if you use any digital camera, if you connect that color signal to an algorithm, you can actually measure your heart rate just by looking at the color in your skin and how it changes. And then specifically, usually we look at the green color. And this is a technique that was invented by a few different people, but one of the main algorithms used was done by Professor Ross Picard's group at the MIT Media Lab. And I happened to be working in that group at the time when it was developed. And my group has adopted this, and we were one of the first people to do this on an Android phone. So you can build an Android phone app that points at your face, and you can measure your heart rate just from just from the signal from your skin. But of course, you have to, because it's a video signal and it's a camera, you can't move. You have to hold still. But if you're not moving, it's one way you can use to measure your heart rate, remotely. And I think some of the applications for these technologies that many people have looked at is to embed them inside furniture, for example, like your sofa or your bed. But we can also have something like this, which is a mirror. So in the morning, you could wake up and you can stand in front of the mirror and it could scan your body, and the mirror can measure your heart rate and heart rate variability. And maybe it could do other measurements on you as well. But essentially it can give you some assessment of your health. So one of the challenges with heart rate variability is that, as I mentioned to you, the heart is connected to both the sympathetic and parasympathetic. So sometimes, let's say if your heart rate goes up, you don't know whether, does that mean that the parasympathetic activation went up, or does that mean that does that mean that the sympathetic activation went up, or does that mean that the parasympathetic went down, right? So like if you're driving a car, there are two ways to speed up. You can basically let your foot up off the brake, or you can give it more gas. And so to help differentiate between that, we look at another signal as well, which is I'm going to introduce here, and that is skin conductance. And so as we know, all over our body, we have sweat glands. And when we sweat, it changes the conductivity of our body, so the electrical resistance of our skin. And this is a function of our sympathetic nervous system. And this is one of the oldest psychological measurements or psychophysiological measurements that goes back probably a couple hundred years. And we know that there are different kinds of sweat glands in our body, and there are some people who study this in greater detail, but people have looked at, for example, the eccrine sweat glands are the ones that we mostly study. And one thing that's very important to also note is that the sweat glands are not the same all over our body. So the signal that you get, for example, from my elbow is different from the signal that I get in my shoulder, or from my wrist, from my finger. So it's not all the same. So the sweat glands are all over our body are different, and you get different signals. But this has been used for many different things. So probably the most common one is, you may be familiar with a lie detector that's used maybe by police detectives or somebody in the legal area for testing people to see if they are lying, basically to see, are they feeling stressed when they're answering questions. And there's been other groups that have looked at this also as a tool for giving biofeedback and basically to sort of guide interviews of people. On this slide, I show some of the instruments that we have used. So the classic place to measure skin conductance is sort of the inner parts of our fingers, our first two fingers. And but what we were interested in, because we want something that's portable and mobile, I developed a sensor band that goes around your wrist. So we wanted to measure skin conductance on your wrist. So the question is, does the signal on your wrist correlate with the signal on your finger? You know, can we use the skin conductance from the wrist as a proxy? And the answer is yes. So this data from some of the work by one of the graduate students at the time. And as you can see here on the right side, the signals from in red color correlate with the signals in that are the gray and blue color. So even though the magnitude is different, you can see that we do get similar types of signals from both locations. So they can be used as a way to assess stress, but there are some differences in amplitude, which can be important for other things, but I'm not going to go into detail on that right now. The other thing I want to mention quickly, since many people ask me this question, so I put in some slides. So because the conductivity of your finger changes, it affects the electric field, right? So if you touch something that has an electric field, that electric field will be modified by your finger, and the conductivity of your skin, as I mentioned to you, is different at different parts of your skin. So this is actually related to you know, what some people know as you know, GDV or Kirlian photography, where people place a high voltage and they try to look at the conductivity of your skin. And so what we're looking at here, even though, you know, you see these pretty pictures of like the high voltage aura, it's really just a function of the conductivity of your skin. And so I don't have an opinion on GDV, and I don't work in Kirlian or GDV, but I just want to point out the connection here to skin conductance, that there are some, it is an area that can be researched further if people want to study that. Okay, so so as I mentioned, I'm interested in ways of making this portable. So we made a version that goes on the wrist. We also made a version that goes on your ankle. And this is what some of the electronics look like inside. And, you know, this is a picture from, gosh, it's almost from 10 years ago. Some of the early Android phones. We built a mobile app that connects these signals to a mobile phone so that you can actually see this feedback in real time. And here we have data from one student who wore this sensor for 24 hours. And you can see some of her data. So for example, you could see in the morning, there was a small peak when she was catching the bus. Then there's a bigger peak when she was playing sports. She was playing squash. Then she was working in the glass blowing lab, had some bigger peaks. Here, there's an important phone call. There was a peak. Then one very interesting thing is during her sleep, she got these very large signals during sleep. So what does this mean? So from this graph, we can see a few things. We can see that your sympathetic nervous system gets activated from different kinds of stimuli, right? You can have sort of a cognitive stress. So if I'm thinking about a math problem or solving a difficult, you know, puzzle, that could be a cognitive stress that produces a signal. I can also have physiological stress. So when I'm exercising, that can also produce a large signal. But the type of signal that we're interested in is the psychological stress. So as you can see, maybe an example here might be when you receive an important phone call. So things that are just not related to either cognitive or physiological stress. And the other important thing to mention here is that we were not expecting to see too much activity during sleep, and we were quite surprised to see that our brain is actually quite active when we sleep. And during our sleep, there's actually a lot of emotional activity in our brain, and that shows up through our skin conductance. And that's become a very interesting signal to study for sleep research. One of the first areas that I worked on with Professor Ross Picard at the Media Lab, and I should say that Professor Ross Picard is one of the main pioneers of skin conductance and especially mobile skin conductance measurement. So my job was to build the instrumentation, and then this instrumentation was then used by many other students for doing various projects. So one of the sensors that I built was used for babies, and at the time we were interested in looking at autism. And as you know, autism, well, some of you know, autism is a developmental brain disorder, and it impairs our social cognition, or our ability to both communicate our emotions, but also to understand emotions. And it's quite prevalent throughout the world. So why is technology useful for this, you might ask? So I'll show you on the next slide. So for example, if you have a child who has autism, and let's say it's a very more severe autism, like lower functioning, sometimes these children, they cannot express when they're feeling stressed, right? So if there's something is bothering them, like they might be very sensitive to lights or sounds or some activities, and their emotion keeps building up and building up until finally they will have a meltdown. So they'll shout out, or have some angry outburst. But if you have this technology, if you have these sensors, you could monitor the sympathetic nervous system arousal, and you can see that they're getting stressed. And so before it gets to the point where they have some outburst, you can intervene. You could give them some soothing activities. You can relax them. You can bring them back down. So as you can see, this is a useful technology that could be used for teachers, but also potentially for parents as well. So it sort of gives you a window into what's happening inside that the child cannot express. So I have also done work with Professor Anne Graybiel, who's one of the top professors at MIT in neuroscience, and she works in the area of addictions, and she's also very interested in other sorts of brain functions, and she does a lot of work with animals and non-human primates. So I did some work for her group, building sensors into basically making wearable sensors for these monkeys, or well, to be more precise, a non-human primate. And these are rhesus macaque monkeys, which you find all over India. And I built sensors that measure both the heart rate variability and also the skin conductance of the animal. And here's some sample data. And what's nice is that these monkeys can wear these sensors for 12 hours at a time, and when they're put in their cage, they can interact with other monkeys, and they're allowed to roam around. So they live in a very large cage, and they can freely interact with other monkeys, and you can do different kinds of experiments. So you can actually study behavior. So this is obviously not something that you can practically do with humans, but with animals, you can set up a condition where, for example, I'll show you on this next slide. You can do experiments such as, for example, you give food to one monkey, but you don't give food to another monkey, and you can see what happens. So maybe one monkey gets angry, and you can also see dominant and submissive behavior. So you can see sort of simple examples of very primitive behavior among the monkeys, and you can see how that's expressed through these signals in the autonomic nervous system. All right. The next thing I want to mention is just zooming out. What if you wear these sensors for a week? So this is an example of a long-term, there's a 1 week's worth of data. And one thing I want to point out here is that, as you can see, there's different activities that produce a skin conductance signal, as we discussed earlier. But as you can see, the sleep signal is quite unique. So when I see skin conductance signals, I can very quickly tell you when the person is sleeping, because the signal during sleep is very unique, and you could easily pick it out. And it has interesting structure. And as you can see, it looks like a shark's fin. It sort of bends over and then has a steep drop. And because of this, some students in Professor Picard's group at the Media Lab did a lot of work with sleep and trying to investigate, where these signals come from and in which stage of sleep do they appear. And one of the things I found out is that these skin conductance signals, these skin conductance peaks, generally appear during slow wave sleep. So, and you can actually measure different periods of sleep, looking at these signals and using them in conjunction with other signals to help you do sleep staging. The other thing that was discovered as part of this work, was that we discovered that one of the people that was wearing these sensors had a very large peak. And initially we didn't know what it was, but we later discovered that it was due to seizures. So as you might imagine, if somebody has epilepsy, so an epileptic seizure is essentially like an electrical storm in your brain. And not surprisingly, that shows up as a very large signal in your sympathetic nervous system. And these signals are so large that, as you can see, even compared to our sleep signals, which are usually quite large, the seizures also produce a very large peak. So this technology can be used as a means to detect seizures, specific types of seizures. And that could be useful also for parents or for people who are trying to detect, let's say, when their child or their loved one is having a seizure, so you can go help them. It could sound an alert or an alarm. And because of that, Professor Picard she did a startup company, which is still around, called Empatica. And one of the products they make is these skin conductance bands. This product happens to be called Embrace, and it's used as a method for detecting epileptic seizures. So so that's just another example of how this technology can be used. Now, the last thing I want to mention about skin conductance is that there's a challenge of what we call valence. So those of you from chemistry might remember that valence means like positive or negative, right? So if you have a high skin conductance signal, that means you have high sympathetic activation. That could be caused by two things, both valences, right? So it could be that I'm angry or that I'm upset, but it can also be that somebody just told me a joke, so I was just laughing. So I can be very positively stimulated and still have a high sympathetic activation. So how do you know the difference between negative valence and positive valence? So that is a classically difficult problem in the skin conductance field. So so this has not been completely solved, but I just mentioned to you a few things that we looked at, back, when I was working with Professor Picard. So in the 1990s, the people did actual physical stimulation of the limbic system in the brain and the amygdala. And by actually probing different parts of the brain, they noticed that the left and the right sides of the body are mapped to the left and right sides of the brain. So it's ipsilateral, not contralateral. So the right side of the brain is the right side of the body, the left side of the brain, the left side of the body. This has been verified also through MRI studies. And with this in mind, people have also, as part of these MRI experiments, people have looked at different kinds of emotions and tried to see that asymmetries in these brain structures and asymmetries in the brain activity. So if you see asymmetry in the MRI data, it's actually not surprising that you also see those asymmetries in your skin conductance data. So an example is here. So this happened to be somebody who was wearing two skin conductance bands, one on the left wrist and one on the right wrist simultaneously. And somebody in their family had passed away. So they were grieving. And during that grieving time, the right side signal, which is actually in this picture is shown in red, it was suppressed. So for 2 days, even during the sleep. So what's interesting, even during the sleeping time, it showed this asymmetry. But then after 2 days, that asymmetry started going away. So the person was recovering from their grief, and now the signals between the left and right were more balanced. So, you know, we don't completely understand this, but it gives us some interesting insights, showing us that if we're able to measure skin conductance in different, both sides of the body and look at these asymmetries, that's another signal that could help us understand not just sympathetic activation, but also valence. And these sorts of signals and technologies that I've been just showing you are starting to be applied to many areas besides just the ones that I showed. People are, of course, in general, trying to understand, stress and anxiety, but also one area that I'm close to is I collaborate with people who work in drug addiction, and you could look up, for example, papers by Marsha Bates and David Eddy on that topic. Lots of people understanding sleep, and people who have studied like the connection with pranayama and heart rate variability. You can look at papers by Bashillo and Layer, and of course, some of this probably goes back hundreds or thousands of years in India, but with the names I gave here is just some of the more recent, within the last 40 years or so, it's been studied here in the Western medicine. Okay, I know we're coming towards the sort of the last section of our talk, so I'll try to go a little bit faster. So I've talked about heart rate variability, I've talked about skin conductance, so I want to say a little bit about respiration. How is respiration measured? Now, of course, in the hospital, you have these machines that look at, they measure your exhaled carbon dioxide. And, but if you don't have these machines, what can you do to measure? Are there simpler ways of measuring this? Well, when we exhale, the air exhaled from our body is humid and it's warm. So you could use a resistor, and you could measure the increase in conductivity as you breathe on this sensor, or you can measure the change in temperature because our exhaled breath is warm. Other technologies that very simple that people have used is they take a variable resistive sheet, and they make a band that you put around your chest or your diaphragm, and when it stretches, it changes resistance. So by measuring the stretch of this, it measures the motion of your diaphragm, your chest going in and out. But one of the problems with a lot of these is, for doing measurements such as sleep studies, we don't want to have all these sensors. We don't want to have all these wires. So my interest is, can we find a more comfortable way of measuring these signals? And ideally, we'd like to have some kind of box or some kind of sensor, like a mirror that I showed earlier, that you can stand in front of this device, or you can sit in front of this device, and you can do some pranayama, and it could measure your breathing. So technology that my group has been doing a lot of work in the past 5 or 6 years has been what's known as thermal imaging. So these are special cameras. They're not measuring the visible spectrum, but they're actually measuring the radiated heat from our bodies. So our bodies are radiating heat. We're radiating thermal energy. And there are now lower cost devices that you can attach to your phone to measure this. This is a diagram of your nose. So the main thing I want to show here is that our nose has these blood vessels. So and mucus film. So when we exhale, the air that's coming out is warmer than the ambient air generally. And what we did is, we built this setup where happens to be one of my students who did this work, and we published a paper on it a few years ago. So there's a tablet, and as you can see, at the bottom of the tablet has this thermal camera connected, and the tablet is basically looking at your face and your nose, and it's measuring the temperature of the air coming out of your nose. And so you can write some software that does this automatically. And here on the right, we show a plot where you can see the red and the blue trace. Here we're comparing a standard belt that measures respiration with the thermal image respiration measurement, and you can see they track fairly well. So for sort of slower regular breathing, it works reasonably well for doing kind of basic pranayama. One of the things that's interesting to note here is because we can measure each nostril individually, this type of sensor gives us the ability to measure left nostril breathing and right nostril breathing separately. So if you're doing some very advanced pranayama, we can actually measure the flow of the air from the left nostril and right nostril separately. And that could be interesting for some people who are doing some advanced exercises. Okay, so now I'm going to step back and just mention some general topics related to technology and wellness in general. So one of the things I want to say is that we have a very strange relationship with technology, right? And I think today, especially the younger generation, we grow up with technology, and the technology is almost part of our body, right? It's like an extension of our brain. And we now have a field of, known as mHealth, which includes not just the phones, but also wearables. And this is now becoming a larger part of medicine, especially for outpatient care, ways of monitoring our health when we're not in the clinic. So there's a lot of opportunities to integrate technologies into what we do. And we also have the opportunity for what we call mobile interventions. So if the body can monitor what's going on inside our brains and inside our bodies, the technology can also detect when there's a problem, and it can also give us some alerts, some feedback, and it can also help to teach us to do some interventions, some exercises to help improve the situation. For example, if it detects a stressful signal, it can detect that and then send a message to say, okay, it's time to do your pranayama. So then you can relax and then do your pranayama, and it could give you kind of a guide or instructions. So these are all good things, and I see this as a feedback loop. So today, one of the main fields of technology is known as artificial intelligence, all these algorithms. And when I was a student, the area that I worked on was Internet of Things. So basically all the technologies around our homes, which could include, our doors, doorbell, our refrigerator, the lights, as well as our phones and wearables, and of course, things like Amazon Alexa or other devices. So these are all devices that are connected and can talk to each other as well as talk to us. And that's known as the Internet of Things. So that, together with artificial intelligence, that's a very powerful technology platform that can both monitor what we're doing, but it can also give us feedback to help us guide our behavior and help us to live a healthier life. So, but one question to keep in mind, remember at the beginning of the talk, I was asking what is health and what is healthy? So I'm always thinking about that. So technology you have to be careful because it's a double-edged sword, right? Some people don't like technology because we know that technology can make our brain lazy, right? Before I had a phone, I used to memorize everybody's phone number. So I memorized maybe like 300 phone numbers. You can ask me anybody, I knew their phone number. As soon as I had a mobile phone, within a few weeks, I forgot all those phone numbers. So similar with GPS, like I think technology, our brain is very smart and our brain adapts. And if you have this other thing in your life that's technology, our brain can become lazy and it can rely on this other thing. And that could be unhealthy because it can form a type of addiction and a dependence. And that's something that we don't want. So you have to be very careful and be aware of your relationship with technology and how you use it. So, in this picture, people are just showing that an iPhone can be as addictive as like a drug. And then, of course, technology affects how we interact with other people, right? And if we're just interacting with our phones, sometimes you go to a restaurant and you'll see two friends together they're sitting together at a restaurant, but they're not talking to each other. They're looking at their phones, right? Or there might be two people sitting at the same table and they're sending each other text messages instead of talking to each other. So the technology is affecting our social connection and social isolation. And some people are also very worried that there are a lot of dystopic stories and dystopic predictions about where this can lead if we're not careful how we use the technology, and that we always have to remember that social connection is important. So one of the most important things I want to say with regards to technology is I think of it this way. So this picture is a picture of training wheels for a bicycle, right? And those of you who learned how to ride a bicycle may have used these training wheels. So how do you use training wheels? So a training wheel is something you attach to your bicycle while you're learning how to ride a bicycle, right? But what do you do after you learn how to ride? After you learn how to ride the bicycle, you're supposed to remove the training wheels, right? You don't keep the training wheels on because you will never learn how to ride the bike. So I think this is how technology should be used. Technology can be a wonderful tool to teach you these skills, make you aware of your body, but it should be used together with a program. And when this is, when you've developed those skills, you should have self-agency so that you don't rely on the technology. So the other way of thinking about it is, technology can be used as a little boost, like I show here. You have a bicycle and you're pedaling the bicycle. It could be like a little motor that helps you to go up a hill, but it doesn't pedal for you. So this is not a two-wheeler, this is not a motorcycle. You still have to pedal. So you still have to do the work. The technology is just helping you. It's not doing the work for you. So in summary, I will summarize like this, that some of the future technologies where a lot of this is going, I think it's going to include not just phones, but also things like wearables. But it will also include, some of the sensors that I work on with, which are wireless and non-contact. You could put this technology into our home. So it could be inside your sofa. It could be inside your bed to monitor your sleep, for example. It could be inside your car, or let's say in the airplane seat. It could be in a hotel room to make you more relaxed and comfortable. And the main point is that it's monitoring you and giving you feedback. So technology has two main roles to play. If some of you are older and remember the original Star Wars movie from like the 70s, the technology can be like R2-D2, which is basically your friend and your assistant, right? So technology can help support you, but the technology can also be like another character in Star Wars, which is Yoda, which is a teacher. So technology can be like the coach to help you develop your own skills, and like the character in Star Wars, it could help you to become like a Jedi or a Jedi Master, basically to unleash and discover your own internal powers, right? And so the analogy, I think, is pretty similar for how you can use technology. And the last thing I want to say is, in many of these technologies, we need to have a way to scale it, right? We need to have a way to get this all over to a lot of people. And technology can also help with this, because now we have technology and the internet. So we have internet and phones. Many people have internet and phones, and more people are starting to have these devices in their homes. So you can start creating technology that can be used by all people, not just you don't have to be an engineering student to use this technology, right? You could be an older person or a younger person. This is really for everyone. It's for ordinary people. And I think maybe you could summarize it by saying, technology is a way to help ordinary people do extraordinary things. So I think I will end here and take any questions that you may have. And I have, oops, I have my final slide, but for some reason I can't go to my final slide. I don't know why, but my final slide is just my contact information. But maybe Elizabeth or others can share that with you all. So thank you very much.
Thank you so much, Dr. Fletcher. We can certainly put your contact information in the chat for participants. I just want to say thank you so much from just a personal perspective, from the university perspective, and I'm sure from all of the participants. That was fascinating. We're so grateful, humbled, and just amazed by the knowledge that you shared. I'd just like to comment a few things, but I'm going to take a minute before we have Q&A to just share a little bit about my own yoga experience, my yogic journey, I guess, and how my time at VaYU has been a part of that. So just to begin, I want to share my screen. Okay. Okay. Can you see the screen?
Yes.
Okay, perfect. All right. So I'm just going to play you a short video, but I'll give you a little intro first. And I'm sorry, I'm learning how to use this technology. So in short, the practice of yoga, and I'm going to be very clear about what I mean by yoga, because particularly here in the West, it's often misinterpreted or translated differently than what I know to be yoga and what VaYU teaches to be yoga. So I'll refer to it as holistic yoga or the integrated approach to yoga therapy. So very much like you spoke of, Dr. Fletcher, the whole complete package, not just physical movements or things like that, right? So including mantra, meditation, pranayama, philosophy, all of those components, as well as asana. So the practice of yoga, holistic yoga, has completely transformed my life. I'm just trying to give you the short version because we're running short on time. Prior to yoga, I suffered with very severe addictions, mental health issues my entire life. I wish actually that one of the devices that you invented, Dr. Fletcher, were possible for me as an infant, because I was born quite traumatized. I'd gone through very, very severe traumas throughout my life, and I struggled to function on a daily basis. And for me, and the definition of health we're given from the World Health Organization and in VaYU has a lot to do with function, how we function, not just the absence of disease, right? So how we function mentally, socially, physically, spiritually, even. And, yeah, I just struggled a lot. I have a few disorders and disabilities. And at age 37, in short, I just let go. I just surrendered, kind of checked my ego and just was like, I give up. And miraculously, yoga entered. And what has followed since has been nothing short of divine grace. The first question comes from Lali Peru Bamba. And it's in regards to autism and stress. And she asked, is that parent stress while carrying the child based on science, on the science you mentioned?
Yes, are you asking specifically about the parent stress as opposed to the child stress?
Yeah, so does the parent stress while the child is in the womb correlate to that?
Yeah, there have been some people, some researchers that have studied the effect of maternal stress while the fetus, the baby's developing in the womb, and they have shown that there are effects on the baby, the resulting baby. So the stress of the mother during pregnancy is important, as well as the overall health of the mother. I have not personally done that work, but I have seen some papers in that field. I know some of the researchers are from Columbia University in New York, yeah, if you Google that, you could find that that's important.
Yeah, thank you, Dr. Fletcher. And just to add, we had 2 modules in one of our yoga therapy classes specifically about that in the program. The next question, the next question is, although verbal feedback can be subjective, is there still a good place for it in such research?
Sure. Verbal feedback sometimes can help you express something that you cannot express through technology, right? So there are still, even in the most advanced studies, there's still a value for language, using language both to describe how you're feeling, to help the computer better understand what exactly it is that you're feeling. And also language is just a natural interface. So not only do we want to express to the computer using words, but we also like when the computer talks to us using words instead of just using numbers. Some of the more natural interfaces just use language, such as Amazon Alexa, for example. So yeah, I hope that answered what you were asking. Yeah.
Very good answer. Very technical for myself. Next question. Dr. Fletcher, you talked about heart rate variability. Constant change in heart rate, is it healthy or not?
Well, heart rate variability is a good thing. But when I say heart rate variability, that's the beat to beat variation, right? So our heart is speeding up and slowing down in very small amounts. If you have huge jumps in your heart rate, that's probably unhealthy. But what we generally mean when we say heart rate variability, we're talking about small deviations in your heart rate, just moment by moment, as you're breathing, and that's a healthy thing. Oh, sorry, you're muted. Yeah.
Thank you. Thank you, Dr. Fletcher. From a yogic perspective, very first semester, first class, we're taught about the length of our breath and how it equates to the quality and the length of our life, right? Which yogis have been teaching for thousands and thousands of years.
Yeah.
I'm not sure I understand this question, but you may, Dr. Fletcher. Please expand on EDA.
Yeah. So EDA is the more general term for electrodermal activity, which is basically all the activity inside your skin. So your skin is an organ, and this skin has nerves and sweat glands, and gases come in and out through our skin. So it's a living, breathing organ, and most people in the psychophysiology world use what we call skin conductance or galvanic skin response. But the more general term for studying the properties of our skin is electrodermal activity. So if people want to know more about EDA, there's a book. So sort of the main book on EDA was written by somebody who just died a few years ago, but the last name is Booksin, Boucsin, I believe is how it's spelled. So if you could look up the book by Booksin, there's a second edition that is out that he wrote just before he passed away. It's Boucsin, I believe. Yeah. Okay.
Thank you, Dr. Fletcher. I've put that name in the chat as well. The next question, are you good for time still, Dr. Fletcher?
Yeah, sure.
Okay.
I'm okay.
This is from Sanjoy Sarkar. Dear sir, I would like to hear from you that how can we control the overuse of technology as it has become the part of daily life and people are getting connected to? And also children are very much interested to play games on their mobile phones rather than study. So any recommendations from you and your years of wisdom?
Well, I'd say, experience with technology is different from experience being a parent, right? And, parents need to be parents, and discipline is always important, and we need a balance in everything. I'd say, one of the most terrible things I would say about modern culture is that we want instant gratification, right? So I could make a general comment like, we want everything fast. We want FedEx. We want packages to arrive immediately the next day. We want to order something online, and we get angry if it doesn't arrive tomorrow, right? And same thing with medicine. We go to the hospital. We want immediately to be cured. So we have this pill that immediately treats the symptoms, but does not really treat the diseases. So this immediate gratification is a difficult challenge because we need to learn delayed gratification, and we need to learn patience and sort of doing hard work and taking a long journey to get there. So that's more of a cultural problem. It's not specific to technology, but technology is just one piece of that. Technology can make our lives very comfortable, but we just have to be disciplined and not rely on it. Like, for example, this is just, an example, but even though I forgot most of the phone numbers that I used to memorize, I still force myself not to look at my phone, and I still dial my phone numbers from memory just so I can use my brain. The same thing with GPS. When I'm driving in a car, I often turn off the GPS, not because I don't like GPS, but because I only use GPS when I am new to a city and I don't know where I'm going. But once I go there the first time, the second time I go, I turn off the GPS and just close my eye. Well, I don't close my eyes while I'm driving, but I look in my brain and I could imagine the map of where I am, right? I could imagine which way, this way is north, I'm heading towards this direction. You can picture that in your mind. So if you force yourself to make an effort to use your brain all of the time, your brain will continue to stay alive, and those parts of your brain will stay alive. If you don't use the part of your brain, you will lose it. That ability will go away. And you can imagine there's probably many other parts of medicine. We rely today on medicine, we rely so much on machines, right? We don't rely on more natural ways of diagnosing disease by really, touching the patient, looking at their eyes, looking at their tongue, feeling them, talking to them. So I hope that as we evolve as a culture, we will not lose some of these natural ways of interacting and remembering how to always use our brains.
Beautiful answer, Dr. Fletcher. Thank you. And to add again from the yoga perspective a little bit, which is in direct alignment with modern science, honest, like it's the same. It's just, I guess, at a different lens. The very first sutra from Patanjali is, of course, now I'm forgetting it in Sanskrit, but it's about yoga is now, right? Atta yoga anusasanam. Yoga begins now, and it's about being in the present. And the yogic path is a disciplined path, like Swami Vivekananda teaches. And exactly what you said, right? That's consciousness. That's choosing to be present with what you're doing and make the choices to live your life. And for many of us, especially people with disabilities or mental health issues, that can be a challenge. From my own experience, yoga taught me how to do those things. Much like the tools that you mentioned, yoga is a self-healing and a community healing tool, right? It's increased my willpower, increased my strength, taught me how to eat, when to eat, things like that, right? So very much exactly what you're saying. And I am amazed by the technology that you spoke of and how much more it can contribute to not just yoga, but for this context, to the credibility of yoga, right? I mean, Dr. Fletcher, you're aware, many of the participants are aware that yoga is not just exercise. It's not this workout, jumping, pumping thing, but so many people think it is, and they don't even look at it as medicine. And that's starting to shift, you know, with things like VaYU and people of your caliber, you know, showing interest. And that's going to change. And it already is. And I think this technology is just another way for us all to evolve and to contribute to this ancient medicine. And it's up to us what we do with it. Last question is from a fellow student, Lataji, and she's asking if you're aware of Dr. Fletcher. Is there any valuable device that mothers should or could wear during childbirth to get alert of any complications? Unfortunately, she lost a friend and her baby recently, so she's wondering from a, very sorry, Lata, she's wondering if you know of anything.
Well, childbirth is very complicated. There's a lot of things that could go wrong, but you know, of course, the medical field has made an effort to encourage mothers to give birth in a facility so they can have access to technologies that can help monitor the baby. But I think one of the, you know, I've collaborated with people working in maternal health, and I think one of the main things is there are sensors out there now and technologies that can be used to before you give birth to detect if your baby is doing okay, your fetus, the fetus is okay, and if there's any problems with the pregnancy, and if there is, then the mother will generally go to a location so she could be close to a hospital or close to a clinic, and then have easy access when it comes time to give birth. And during the birth process itself, there are, you know, devices, things like a partograph that monitor both the vital signs of the baby and as well as the mother, as well as, you know, the contractions using EMG and so forth to make sure that everything's normal. And they monitor like the baby's stress and the heart rate variability of the baby. So yeah, those technologies are out there. I'd say what's new is there are a lot of people who have been making portable versions of these instruments that could be connected to a mobile phone, and they could be used even if you're in a remote village. There are portable versions that can be used, and hopefully in the future these will be more accessible to people. But anyway, I hope that answers the question. And I think the other thing I should mention, this connects to the earlier question, which is sort of that there are starting to be more tools to help support the mother's mental health during pregnancy, as well as after pregnancy. As you know, there's also postpartum depression is another you know, pathology that is important. So I think having more tools to support a woman's mental health before and after pregnancy, that is also improving and becoming available.
Thank you. That's a very thorough and empathetic answer. I'm not sure where you're at for time, Dr. Fletcher. We've gone over, and you know, my guru says Hari Om, it's all divine, and I believe that, but I want to be respectful of your time. There are just a few more questions, and then we just have, you know, a 2-minute close. Are you good to proceed, or?
Sure. Yeah, I'm okay. Yeah.
Okay, perfect. Thank you so much for being so generous with your time. This may be a private question. Maybe someone can email you, but they want to know if you do speak at high schools to help young adults see how balance can help. Tech, as you have shown, can help and have such a distinct role when used in balance. So do you speak anywhere?
Well, it's good. It's good that you're at. It's a good question, and I've recognized that need. What I've started a couple years ago, I started a new class at MIT also includes students from Harvard as well, is called Technologies for Mental Health and Wellness. And I helped start the class specifically to help address some of these things about technology, the proper relationship with technology and how it could be used and also misused and abused. And we're trying to turn that class into a book, a book that we will sell and have available in the future. And my co-instructor, who's the co-author on the book as well, her name is Dr. Karen Hodges, and she's a child psychologist. So we think a lot and very deeply about the development of the human from birth to adulthood and how technology influences that development. So it's that's a whole talk in itself, but yes, I appreciate the question. It's a very important topic, and right now we're trying to have a class, a book, and maybe in the future maybe have a podcast on this. But yeah, we've thought about all these things. And hopefully I'm not the only person talking about this too. I think, smartphones are only 10 years old, right? Which is amazing that it's just been 10 years, but we don't know yet how technology is going to affect us. Maybe 100 years from now, we're going to look back and we might say, oh, do you remember 100 years ago when they invented the smartphone? Wow, like look at the stupid things that we did back then, right? So I think, in the future, we will have a better, we will have more experience with technology, and we will know better what we did wrong and what's the right way to use technology. But we're still learning, and but hopefully, we'll be smart enough that we could, adapt and learn quickly.
Beautiful. Thank you so much, Dr. Fletcher. There are a few more questions, and I'm just going to direct people to Dr. Fletcher's email because we could go on all night. And as MC, I got to redeem myself here.
Sure.
But in closing, I just want to remind everyone that more information about all of this can be found on the website, VaYUusa.org, as well that the admissions are open for the fall. So application related questions can be sent there. We have a few open houses coming up. We've provided Dr. Fletcher's contact information. And a lot of the illnesses and lifestyle diseases that we've talked about tonight and highlighted can all be prevented and managed with yoga. If you're not able to take this program, you can reach out to yoga therapists. If you don't know of one, you can connect with VaYU and we can certainly help with that. There's a litany of information available, but most importantly, and yoga teaches us this as well, that we all have that inner wisdom, that inner knowledge inside. And Dr. Fletcher, you highlighted this very well. When we know better, we do better. And silence is one of the most powerful answers. And yoga teaches us to calm the fluctuations of the mind, silence ourselves, and to go in. And sometimes the answers, often in my experience, the answers are already within, and yoga can help support us in that. So with that, we're going to officially close the webinar. Okay. And there's just a number of quick things. Can you see the screen fully this time? Perfect, good. So there's the contact information for VaYU. Technology for yoga practice and research is a very fascinating topic. There's so much interest. Thank you for being so generous with your time and for explaining it so well, Dr. Fletcher. Thank you to all the participants.
Sure.
For your patience, for understanding my technological issues. And we're going to close with a prayer. I'm sorry you didn't get to see the opening one, but we'll close with the closing one, and hopefully you can see that on your screen. This is a mantra from the Upanishads, and it's often referred to as the loving kindness mantra. If you're comfortable, you can close your eyes, Sit up nice and tall, grounding into your seat and lengthening your spine. When our spine is long and straight, our nervous system relaxes. And take a deep breath in through your nose and just sigh it out your mouth. Inhale through your nose and let it all go through your mouth. Beautiful. If you're joining, palms can come up to your heart in Namaskar Mudra. You're welcome to join or listen. Om Sarve Bhavantu Sukhina Sarve Santu Niramaya Sarve Bhadrani Pashantu Ma Keshit Dukkha Bhagave. Om Shanti, Shanti, Shanti. Thank you so much, everyone.